Implementing security. All right, SQL Server 2005 security. Let's jump right in ahead first here. We're going to start off with a big look at the architecture of SQL Server 2005 security. And really, some things have changed. A lot of things have changed, actually. But the big thing is schemas. We're going to talk about schemas and get you introduced to schemas and how they work in SQL Server 2005. And also some terminology has changed. We're going to talk about principals, securables, and permissions. So if you haven't heard about these things at all yet, don't worry, they're really just carried over from SQL Server 2000 with new names and features attached to them. But we'll cover all that in a big overview of our security architecture. We'll then move into working with all of this inside of SQL Server Management Studio through managing security. So we'll talk about how to create schemas, how to create principals, how to grant permissions to securables to principals, so on and so forth. And also another thing I want to mention here, when we start doing these demos, I'm going to show you kind of how to do it from the administration perspective, and that is, of course, using the interface and the dialog boxes in SQL Server to click around and create these logins and grant permissions and things like that. And then also show the development side by doing the same exact thing, only using a script to do it rather than the interface. So we'll cover both sides of that double-edged sword there when talking about administration versus development. And then we'll also move into execution context and managing execution context. And what this really is pretty much switching your security credentials on the fly. Kind of like in Windows, if you've ever used the run as command to change the context of who you are in that session, we can do the same thing in SQL Server to save us time when we want to do things such as test out security. It's a lot easier to just say run this as another user than actually log in as that user and do it. So we'll talk about all these things when we get there. So let's go ahead and begin here by getting familiar with the new security architecture in SQL Server and also get a handle on some of these new buzzwords that we have. And some of these new buzzwords are principals, securables, and permissions. Of course, permission isn't a new buzzword. That's been around a while. Maybe next version we'll get a new buzzword for permissions, but not this one. Principals, on the other hand, is new. Principals are just simply things that have a security context in SQL Server. So they can be one of three things. They can be a user, an individual user, can be a group of users, or it can be a process itself. So those are pretty much one of three things that is going to be a principal that can have a security context. So principals, of course, request resources from SQL Server, and we have three different flavors, kind of three different levels of principals. We have our Windows principals, and these are, of course, going to come in the form of either a user or a group, and also in the form of a local user or group or a domain user or group. And pretty much we're going to be creating these in Windows at the operating system level. We also have another level. We have the SQL Server level principal, and this is just going to simply be a SQL Server login that we can create at the SQL Server level. And then we have database principals. Database principals sit in the database level and come in the form of a database user. And of course, a database user is either going to be one of these two items. And basically what we're going to do is we create a database user and map its credentials to one of these logins. So that's all a database user is. We'll get there and learn how to create these when we get into a demo. We also have a database role, and a database role is, of course, going to be just a predefined set of permissions, and we can pop users into these database roles so they automatically get those permissions and can do things at the database level. And then we also have application roles, and an application role is kind of cool. I've actually used these in the past when building applications. They're a lot easier way of setting permissions at the app. If you need an application, you basically want everything associated with an application to be able to access certain objects in a database. What you can do is, instead of putting users in an application role, we actually define permissions on objects and we give those to the application role itself. Then an application will come in, and when it requests these resources from SQL Server, it'll actually activate this role. And if that role is active in a session, it'll allow that application to use the security credentials and the permissions associated with this role and get what it needs to. And then when it's done, of course, it'll deactivate the role and be on its merry way. So these are just basically the three different levels of principals. And of course, principals are just simply things that have a security context that are going to request resources from SQL Server. So what are these resources that these principals are going to access? Well, those are securables, and that's all a securable is pretty much a resource. So something that has a permission set is going to be a securable. And at the smallest level, of course, it's just simply an object in SQL Server, such as a table or a view or a stored procedure or anything you can think of. Just a simple standard little object in SQL Server that has permissions is a securable. But because securables can contain other securables, we have nested hierarchies which are called scopes. And that is because we can grant At a higher level, we can grant permissions to maybe one of these scopes or an object in one of these scopes, and then anything in the smaller levels, those permissions will automatically get propagated down to. So that's kind of what the whole scope term is all about here, is just simply saying that we have hierarchies. And to give you an example of that, to take the schema for instance. A schema is going to contain tables and views and stored procedures. If we wanted to just give it to one table, permissions to one table to a principal, then we can just, of course, go into that table and grant permissions to that specific principal. Or if we want a user to have permissions on all of the objects in a schema, we can grant permissions to the schema, and those objects will automatically get all the permissions propagated down to them from that schema. So this is going to make it very handy when you want to deal with permissions rather than micromanage it at the table or the view or the user level. Of course, we're going to need to do that for those little ad hoc quick jobs, but when we're first designing security, we can make it easier on ourselves by doing it at the schema level and doing it at the scope level rather than at each individual object. And just to give you a quick example of some of these scopes, some of the securables in these scopes, we have the server scope. And the server scope, so draw my little icon for the server here, is going to hold things as logins, databases, endpoints. An endpoint is kind of a SQL Server web service, a new object inside of SQL Server 2005. We also have database scope. The database scope is going to hold users, it's going to hold schemas, roles, assemblies. There's a ton of different objects at the database level. And we also have the schema scope, which is of course going to hold tables, views, stored procedures. All of your basic database objects are going to be stored at the schema level. So these are again just examples of what scopes can hold which items. And really what we're going to be doing here is granting permissions to these scopes, and that's where permissions come in. Permissions are your key. It allows a specific action to be done on a specific securable. And we can do one of three things when we give permission or a certain action on one of these securables. We can either grant that action, giving the user the ability to use that action or execute that action on a specific securable. We can revoke that action. So whatever that current state that action is, we can take it away. So if they're currently be denied, we can revoke the deny permission. If they're currently granted permission, we can revoke the grant. And deny is just simply nothing. If a deny permission is on an object, no matter what that principal tries to do to that securable, if that action has deny permissions, then it can't touch it. Now, if we had to create a diagram to kind of give a visual perspective on how all this stuff works, going this way will be our principals. So here's all of our principals, such as our operating system principals. So this is where our Windows domain and accounts would sit. Our local logins, our domain logins, they would sit at the Windows level. Here's where our SQL Server principals would sit. Of course, this would be where SQL Server logins are. Here's where our database principals would sit, or database we'll call this. And this is, of course, where the database user, database role, and application roles will pretty much sit. And schemas, there are no principals for schemas since they sit inside of the database and they don't really have a security context associated with them because they're not requesting resources. Going this way would then be our securables. So here's where all of our securables would be, and you can see, again, at the operating system level there are no securables because we're not inside a SQL Server. But I will say if you are an administrator of the system and you're sitting at the OS level, then by default you have permissions to all of this stuff. But you can see then our server scope kind of sits here. This is where our SQL Server is, kind of how these icons relate to one another. This is where our database scope is. So pretty much permissions go this way. So that's kind of how, if you had to diagram it out, your principals going down, this is pretty much just where everything sits, and this is where their different scopes sit as well. So all of our users and schemas sit here, all of our tables, views, and sprocs sit here, and of course our logins and our databases sit inside of here. So that should give you an idea of how this hierarchy stuff works. So that's principals, securables, and permissions. Now you've been hearing me talk about this schema stuff. Well, what exactly is a schema anyway? So a schema is just simply a container. It is a container that holds all of our database objects. And it kind of sits at this level right here. It's inside of the database scope level. And again, just above all of our objects because schemas are going to hold objects. And what it's going to do is form a namespace. So the namespace is how we resolve objects in SQL Server 2005 and pretty much all previous versions were server.database. Only in the past it was .user.object. Now it's .schema.object. And let me just say something about this, is that really in SQL Server 2000 and prior, we did have schemas. We just had no control over them. We couldn't do anything with them really. because what happened was the user that created the object, that's how the schema would take its name from. It would automatically define itself with the name of the user that created the object. So this became a problem very, very fast, though, because what happens when users leave companies? Yeah, we can't just drop the user because now they're associated and tied to that object. So we had a nightmare on our hands when users left the company and they had objects out there that they created all over the place. Well, now with this whole separation, and also Microsoft gave us full control over the schema, we no longer have that issue. So I know there's a lot of administrators out there clapping their hands over this one, because this was a pain. And if we did somehow manage to drop the user, then we'd have a bunch of objects out there that we couldn't access because they'd have the security identifier tied to an old user. And it was a pain. It was a complete nightmare to change basically the user of this object to the DBO user or another new user. And that was kind of what ended up happening as we got smarter with SQL Server over time. This would come into our planning stages is we'd say, you know what, only DBOs create objects, then we won't have this problem. And that's kind of what happened as far as I've seen in the industry. But now we don't have to worry about any of that stuff because we have schemas and we have full control over our schemas. And very, very nice. And it's easy to transfer objects from schemas, create objects in schemas, and even creating schemas. It's a breeze. So that's all a schema is, just a named collection of objects. It's a container that holds our objects, and it's going to make life so much easier. Not only do we get better organized with schemas, because to give you an example here, say you have a big product, and you have all these third parties that want to integrate with your product. Well, guess what? There was in the past, what we did was we'd use naming conventions. We'd prefix all of our objects with maybe the three-letter prefix of that product or that third-party utility or third-party tables that are integrating with our product. And even that that gets hairy after a while. It gets hard to manage. Now with the whole schema in front of it, it's going to be a lot easier to manage. And you'll see once we get into our test database here, you'll notice our objects are much better organized through the grouping of schemas. Also, permissions are going to become greatly simplified because now we can do it at the schematic level rather than at the object level and micromanage all of our objects, or even at the user level. So things are becoming a lot easier when managing our objects and permissions and securities in SQL Server 2005. Schemas are only going to make it better. Now, before we get into our demo, a couple of notes I want to make about this fully qualified naming convention. When you actually write queries to access our objects or execute stored procedures or take data out of views, we're not going to be using the fully qualified naming path or convention to do this. For instance, actually the only way you will is if you're using linked servers. If you have another server and you want to access data, say we have a VB Nugget server over here, and we set up a linked server in our SQL Nugget machine to access this VB Nugget server because there's tables over here we want. Well, if we're connected to this machine, then yes, we're going to have to use the fully qualified naming convention to access any database objects over here. But say we're not, and we're just connected to this server, and not any database on this server, then we could use database.schema.object. So select star from adventureworks.sales.orders if we wanted to get data out of our orders table. Now, if we were connected to the AdventureWorks database already in our connection, in our session, then we wouldn't have to do this either. We could just say select star from sales.orders, schema.orders. And if we have what's called a default schema associated with our user, something that I'll show you when we get into a demo, you can have a default schema associated with your user. And if you do say we have the sales schema as our default schema, then if we're connected to this server, this database, and we have that as our default schema, we just simply need to do select star from orders. That'll give us all the data out of the orders table. So just to kind of give you a heads up on how this naming convention stuff works. Now, how this would work if you didn't have a default schema associated with you, then you would have to do schema.object, sales, select star from sales.orders to access our orders table. If there was another orders table involved in a different schema, because if there's only one orders table, it knows what you mean. It knows you want the orders table, and it'll automatically grab its data out of that orders table. But if we had, say, a production.orders table, then of course we would need to fully qualify it with the schema namespace. So that's just want to give you a heads up on how this fully qualified naming convention stuff works to access objects within our database. Alright, so enough of me babbling once again. Let's jump on into SQL Server Management Studio and figure out how to do these kinds of things. We're going to go down to Start here and up to Programs and on over to SQL Server 2005 and right down to SQL Server Management Studio. We'll fire this open and I'm going to hit cancel here right off the bat. We don't want to connect to a server right away because I'm going to show you how to do this using our registered servers. And what I did was I created a bunch of registered servers, pretty much all the servers in our environment, all of our SQL servers installed in our environment here. And what I did was I created a bunch of groups. I have this grouped out by our development SQL servers, our production servers, and our test servers. And it's very simple. Just like in SQL Server 2000, you can create a server group. And then, of course, you create server registrations. And then you can just simply right-click on these on a registration, choose Move To, select a group, and boom. So I like doing this, better organization, and just easier to read when you're navigating around inside of your registered servers. But what we're going to do here is we're going to connect to our dev instance over on our SQL Nugget machine by right-clicking, choosing Connect, and choosing Object Explorer. And that's going to throw it down as a node inside of our Object Explorer pane here. And we're going to do the same thing to our production instance. We'll connect to Object Explorer. And you can see now it's kind of like working with SQL 2000 Enterprise Manager. We just have a couple of connected nodes, and we can do all of our tasks as we would using Enterprise Manager. And what I'm going to do here is we're going to use our dev machine, our SQL 2005 dev instance over on our SQL Nugget box to do all of our administration side of things. So we're going to use the interface to create logins and create database users and grant permissions on objects inside the database, so on and so forth. And then we'll use our production machine to run our scripts that'll, again, do the exact same thing. The output will be the exact same and the outcome will be the same. It's just that we're going to do one using administration means, interfaces, dialog boxes, and the other using a script. So let's start off with the administration side. And the first thing we need to do is create some logins. We need users to access the system. So inside of our security directory here, inside of our security node, we have a couple of other directories, login, server roles, and credentials. And what we're going to do is go ahead and create some logins. And this is where our Windows level principles and our SQL Server level principles are going to sit. So you can see these are currently all the users and groups that have access to the system. And if we just right click on our logins folder and choose new login, this is a dialog box that'll begin looking very familiar to you. And basically, like I said, we're going to create a Windows authenticated user and a SQL Server authenticated user. And to do this, we can do one of two things here. If you already know the name, you can type it in up here. We're first going to create a Windows authenticated user, or you can click the search button over here. And this is really handy. You're going to get very familiar with this dialog box if you're not already. And basically what this is Active Directory. SQL Server 2005 is even more integrated with the operating system than ever before. And we can use Active Directory to basically search for anything and everything. And here's what we're going to do. We're going to go ahead and I created a group out there. So what we're going to do is we're going to search by group. And our location we're going to look at is, of course, the CBT Nuggets domain. And what we're going to look for is, I'm going to go ahead and click Advanced here. We're going to look for a group that I created called Quality Assurance. And we're going to give this group access to our SQL Server. So there we go. Quality Assurance. We can hit check names. Boom. No problem. We hit OK. And there it is. CBT Nuggets Quality Assurance. So, a couple of things here. These options, enforce password policy, enforce password expiration, and user must change password at next login, are not enabled to you when you use Windows authentication, simply because it's already in effect. This is a Windows user inside of Active Directory. The local policy is already taken effect. And this is going to come in play when we create a SQL Server authenticated user, and I'll talk about that when we get there. But basically the only thing we can do to this point is give a default database to our quality assurance user, and this is just going to be the default. As soon as this user creates a session, it's automatically going to be connected to that default database. So we'll go ahead and choose AdventureWorks there. Now some other things we can do. Server roles. Server roles these are again server level roles here. And so if we do this, they'll basically have access to the server, certain permission levels at the server level. So the server scope. We have bulk admin, which is just basically allows bulk insert operations. DB creator is basically someone that can create, alter, drop databases and also back up and restore them. Disk admin is someone who's going to manage the disk files, the MDFs and the LDFs of the world on your disk, which of course make up the log files and the data files of the databases. Process admins can stop and kill processes. Security admins can do basically what we're doing, create logins, grant, revoke, and deny permissions both at the server and the database level. Server admins can simply change the properties of a server, basically configure the server. Setup admins can create and drop and alter linked servers and things of that nature. And sysadmins can do absolutely everything in the system. So these are the server roles, and again, they're server-wide security privileges. User mapping, this is where this is kind of a shortcut to basically take this login and create database users for it. So if we did something like this, it would automatically create this database user with this name inside of the AdventureWorks database. Or you can even give it a different name, kind of an alias, and that'll go ahead and create that same user mapped to our login that we're creating here, just with this different username here. But you know what? This is the shortcut way to do it, kind of doing it on the fly. And then you can also give database role permissions for these specific users and these databases that you choose. But we're going to do this a different way. So I'll show you the kind of the standard way to do it. Once you get good at this sort of thing and you're creating logins and popping them in databases on the fly, this is where you'll be doing that. And here we have securables. So this is server level scope securables here because we're creating logins at the server level, right? We're not in any database or any schema at the moment. So we're at the server level. And just to prove that here, if you click on the add button, it's going to ask us, what do we want to do? Do we want to search Active Directory for specific objects at the server level scope? Or let's just go ahead and choose all objects of the specific type. And when you click OK here, it's going to pop open with this dialog box. It's going to say, what securables do you want to basically give permission to? And we'll say server here. The server's endpoints and logins. Again, these are all the server level securables that we can give permissions to. So we're going to hit OK here for the server level securable. It's going to pop in up here, and then we have all the permissions available for that securable. Here they are. Administer bulk operations, alter any connection, alter any database, alter any linked server. You can see these are all server level permissions. Connect to SQL Server, control the server, create databases, things like that. These are all server level permissions. And basically what you can do here is it just shows you the grantor. I'm logged in as the trainer right now, so I am the grantor of this permission. You can either specifically grant this permission, basically this action on this securable. You can say with grant, which would give this group the ability to grant this permission to someone else. And then also we can explicitly deny this permission to this user. So those are securables. Again, these are server level securables here. So I'm going to go ahead and just remove this. We don't want to give this specific group any permission to any securable at the server level. And then one other node we have over here is statuses. And basically what you can do here is you can grant or deny connection to the database engine, enable or disable a login, and then for SQL Server authenticated users only, we can choose to lock out the user. But I think we're all set here. We got our user set up to the default database. We don't have anything else really to do for this user because we're going to do everything at the database level for this specific user. So I'm going to click OK. And what that's going to do is create ourselves a login. Here it is. So another thing we're going to do here is create a SQL Server authenticated user. So let's right click on our login node again and choose new login. This time we'll choose SQL Server authentication. So a couple things are going to happen there. No more searching windows, of course, because SQL manages these logins. And also we're going to get these options down here enabled for us, these three checkboxes. And what this is basically saying is, would you like to take advantage of the local security policy on the SQL Server's installation machine? And we're saying yes. Now one thing I want to mention is these three options will not even show up. In fact, you'll just put a big gray space here if you're not installed on a Windows 2003 server or above machine. So we just so happen to be installed on a Windows 2003 server machine, our SQL Nugget instances anyway, over on our SQL Nugget machine. So we get these options enabled to us. And these options all depend on one another, as you can see here. Basically you can't choose either of these without enforcing password policy. You can't change your password unless you're enforcing expiration, so on and so forth. We're actually going to disable that one. Another thing we can do here is these are kind of the advanced encryption features of SQL 2005. And we'll maybe get into these in a future video when covering more of the advanced topics. But basically it all has to do with encryption. You can create certificates. You can create asymmetric keys using a standard encryption algorithm. You can also create symmetric keys when you want to encrypt columns of data. But again, we'll save that for a future video on more of the advanced topics. Let's go ahead and name this user Temp Tester. So basically what we're going to accomplish here is we're going to create a little bug tracking addition that we can toss into any database and track bugs and issues, issue tracking database essentially. So we'll create a temp tester for that reason. We'll give this user a password of password, only not just any password, the secure version of password with the ampersand, with the @ sign and the 0. And you'll see this when we get into the script. I'll show you how that's spelled. But it's a secure password. So we don't need to do anything else with this user because it doesn't need server roles. User mappings will save when we get into the databases. And we don't need any server level securables. And we know the status. So we'll click OK here. And there we go. We have now a temp tester user. So we have a quality assurance group with some users in it and a temp tester user. And we're ready to go to give these users access to our databases and then set permissions on certain objects within schemas. What we'll do next. Now a couple other things I want to mention before we go over there is server roles. You can see, as I said, you can manage server roles by giving the user a role inside of their dialog box, or you can come down here to server roles and just double click on a server role, and then you can add members into this role by doing the same thing. Now, another thing I want to mention here, server roles are fixed. You cannot create your own server level roles. However, you can create your own database level roles. So, another new feature inside of SQL 2005 is called credentials. And this gives SQL authenticated users a presence outside of SQL Server. So, for instance, if you need to access the file system or you need to access any type of object outside of SQL Server environment, you can map a Windows credential through a SQL authenticated user, and boom, you'll be able to access any kind of resource outside of SQL Server. So that's kind of a slick thing. Now let's go ahead and jump into our databases here, and down into AdventureWorks, and down into Security, and here are all of our security objects inside of at the database level scope. We have users, roles, schemas, the three items that we're really going to be focusing on. Here's as I was talking about earlier, asymmetric keys, certificates, and symmetric keys. Advanced concepts regarding encryption, encrypting data, encrypting users, encrypting passwords, everything. So let's go down to schemas here. Let's create a schema. And you can see here's the built-in schemas for this specific database. Let me go ahead and hide our registered servers pane up here so we get a better view of everything that's going on. And here we go. So just to kind of give you a brief overview here, you'll notice we have a production schema, a purchasing schema, a sales schema, human resources schema, and some of these are the defaults. These are just schemas associated with database roles. You have your standard DBO schema, your guest schema, and just to show you here, if I expand tables, you're going to notice something right off the bat. Look at this. We're going to create tables and then associate a table with a schema, and boom, it's automatically associated with that schema. So we have a human resources schema, person, production, purchasing, sales, and we're going to create our own testing schema for our quality assurance and bug tracking database. So back down here, to create a schema is very simple. Just right click on our schema node and choose new schema, and then give it a name. And we're going to go ahead and give this the name testing. How about bug testing? How does that sound? Our bug testing schema. And you can also give it an owner. You can search Active Directory or search SQL Server to find an owner. We're just going to go ahead and choose the DBO, the database owner role, as the owner. And then click OK. Now we have a bug testing schema. There's nothing in it at this point, but we have a schema. Now we'll be back into that schema shortly so we can add set permissions on the objects inside of the schema, but we need to get some objects in the schema first. So I'm going to go ahead and run up to tables here. Our tables node, I'll right click on tables and choose new table. I'm just going to create just a quick little, call this tester ID, quick little testing table. It's going to be an integer that's not going to allow nulls. We'll also create a first name of the tester. We'll go ahead and make this an nvarchar 50, looks good, and also a last name. And we'll do the same thing here. There we go. So we have a table going on here, and what we're going to do is view properties window to bring up the properties window associated with this table. And here we go, schema, right? If we drop this down, we're going to choose our bug testing schema. There it is. You can also give it a description here, a couple other, again, these are table level properties. But the point is, we now have a table in our schema. So I'm going to go ahead and save this by clicking on the save button. Oh, actually, I'll just close out of it and choose yes. Give it a name. Let's call this testers. As soon as we click OK, I'm going to close out of our property window here to give us a little more room to work with. Scroll on down and check it out. Bug testing.testers. You can see it automatically took the name of the schema, name of the table. That's it. So creating schemas are really that simple. You just create a schema, attach an owner to it, and then whenever you create any of your objects, you just choose what schema that objects are going to be transferred under. So simple as that. Next thing we're going to do here is create some users. So drop down to our security node. We'll expand our user node, right click on our user node, and choose new user, new database user. And we'll get prompted with our standard looking dialog box here. And what we're going to do is first you give it a username. And this is generally, you want to keep this the same as the actual login name for, of course, management reasons, easier all around. But you can give it a different username than you're going to map it. Because what we're really doing is we're creating a new database user and mapping it to an existing SQL Server login. So we'll keep it the same here, temp tester. And then let's go ahead and search Active Directory once again. This is kind of, again, the standard Active Directory looking interface. Very slick. We're going to search logins. Let's browse these logins available to us, and here they are. Here are all of our SQL Server logins. We're going to go ahead and choose temp tester, click OK, and that's all it does is it'll type that in there for us. So what we're going to do here also is give this user a default schema. So This is going to help with the whole name resolution side of things. As I was saying earlier, if you have a default schema, then we don't have to append the schema name before our object names when we're writing queries and such. Same thing here. We're going to search schemas. We click on Browse. There's our bug testing schema. We'll choose that. Click OK. Click OK, and it'll enter bug testing in for us. So we're starting to get the hang of this now, right? No problem. Doing all the searching and finding things in SQL Server. A little different than before, but trust me, it's a lot easier once you get the hang of it. Other things we can do with this user that we're creating in the database level here, our database level scope. This shows all the owned schemas by this user. This user, of course, does not own any schemas. And you can also go ahead and make this user own a schema, but keep in mind that a schema can have only one owner. So if we were to give this user, if we were to do that and then click OK, it would take away the current owner, which is the DBO of that schema. So just be careful when you do that. Also, of course, you have all of your database level, database scope role memberships available to you. And just to go through a few of these, access admin, if we grant this role to this user, it would be able, this user, temp tester, would be able to grant access to this database. Backup operators, of course, back up the database. Data reader is select permissions on everything in the database. Data writer is delete, insert, and update statements on everything inside of here. DDL admin basically is a data definition language administrator. It can create any object. Tables, views, stored procedures, you name it. And then there's some other ones in there too. I won't go through all of them. But just to give you an idea, these are, again, database level role memberships. Also, we have securables. Check this out. If we click, this should look familiar from the server scope securables that we're looking at. If we click add, and we do the same thing we did before, all objects, look at this. Now we have a much larger list of things, of securables that we can grant permissions on. We have databases, stored procedures, tables, views, everything. These are, again, database level scope securables. So we're going to save this though. I'm going to hit cancel here and also cancel here, OK here to create the user, because we're going to save that when we go into the schema. We'll grant them to the schema level just to show you the schema scope level permissions as well. So before we click OK, extended properties, nothing crazy here. You can add your own extended properties if you want to. It's just simply a name value pair, and that's it. And it just makes it, it's good documentation. I use this for documentation personally. I've seen other people use this as documentation. It works. It's, you know, little descriptions here and there on anything you want. So I think we're pretty much set with this temp tester user. Let's go ahead and click OK, and boom, now we have a database user. Now let's go ahead and create our other user here, our other database user. That's our Windows authenticated user. So we'll right click on our users node again, choose new user. As soon as this fires open, let's go ahead and navigate and browse our logins to our quality assurance user. And we'll click OK, and click OK. Here we go. I'm just going to go ahead and copy and paste here. Copy, right click and choose paste to get our same name up here. Now one thing I want to mention here, with Windows authenticated users and logins, you actually cannot assign a default schema to them, and this is Microsoft's bad for even allowing us to go ahead and browse the schemas and choose a schema and waste all our time doing this. Then we click OK and oh, sorry, you can't do that. You can't associate a default schema with the Windows authenticated user. So just the way it is. Again, that's Microsoft's bad for even allowing us to do that and get ourselves into trouble there. But this is all we're going to do here is get our quality assurance user inside of the database, and boom, now we're ready to start setting permissions on objects within our schema and also just any other object. So let's do that. Let's go into our temp tester here, double click on him, back into the securables node, we'll click on add, and this time instead of going to all objects of types and then choosing our types, look at this one. All objects belonging to the schema, and we'll choose our bug testing schema. All your schemas are in here, of course. We'll choose OK, and that's going to go and grab all the objects associated with that schema and toss them in here for us. So it's not that we can really grant permissions on the schema itself for all the objects, but it allows us to search for all of the objects in the schema. It's just, again, much more organized and much easier way to manage everything. So we get our object. We only have one object in this case, our bug testing table. But here's what we can do. Here are all the permissions for the table object. And what we're going to do is, since this is our temp tester, we don't want them to do very much other than just simply have select permissions on this table. They can read. They can read the data out of our testers table, and that's about it. You can also, you can see, you get very granular with tables. You can even get down to the column level permission and grant stuff at the column level, which is very, very nice. So we'll say OK there. That's all we want to do for our temp tester. Our quality assurance group, though, we're going to say this is our internal group. They have a little bit more leeway as far as this table goes. They're going to have a lot more to do with it. So let's go into our securables. Let's do the same thing. Add all objects belonging to our bug testing schema. We'll choose that object, our table, and then we're going to give, how about delete, we'll give insert, and we'll give select and also update here. And why not references as well, in case there's any lookup tables associated and linked to this table. We of course want them to be able to do those lookups, so we'll give them references as well. And that's it. We'll click OK, and boom, permissions are set. So our database is pretty much set up and ready to rock and roll. Let me just go ahead and run through what we did real quick, just because we did do quite a bit there. We started off down here in the security node, which is at the SQL Server level, our server level scope here, and we created a couple of logins. We created a Windows login, quality assurance, which is tied to a group here. You can see that by the icon. And then we created a SQL Server authenticated login called temp tester. The next thing we did is we went into our database, AdventureWorks, our sample database, and we created a schema called bug testing. After that, we went ahead and we created a table called testers, and associated with that bug testing schema, and since we associated with it, automatically appended on the schema naming convention there ahead of it. Then we went into our security node and created two database users and mapped them to our SQL Server logins, and then we gave them permissions to objects within our bug testing schema. And that's all there is to it. So now the next thing I want to do is I want to show you how to do this using a script. So kind of the development side of things. And we're going to do this on our SQL production machine. So I have a script that I'm going to open up here. We're going to open, File. I'm going to choose our script called Schemas, Logins, Users, and Permissions. We're going to open this up, and I'm going to say, yeah, go ahead, connect to that SQL 2005 prod instance over on SQL Nugget, because that's what we're going to be using to run the script against. So what I'm going to do here is just hide our Object Explorer for a second. We don't need that for the time being. I'm going to switch our active database to AdventureWorks. And that's one of the things that would automatically switch if you have the default database turned on for a user. Again, since I'm logged in under the trainer account, my default database is master. But just to kind of show you here, starting from top to bottom, the first thing we did was we created some logins. So let's do the same thing. Here's our temp tester login. We do a create login, name of the login, and any options afterwards, you use the with keyword, and then we're going to say with password. We're going to say, this is a N meaning Unicode characters, password, P @SSW0RD, and this is a strong password. We're using check policy equals on, check expiration equals on, and then we see we didn't do the change password at first login, and then the default database is AdventureWorks. So pretty much the same thing we did in the interface, the exact same thing we did in the interface, and that's all interfaces are anyway, are wrappers around code, which is essentially what this is, the Transact SQL language. So if I highlight this little chunk here and choose execute, look at that, command completed successfully, and now we have a login called temp tester, and I'll show you that in a second. Let's go ahead and also create our Windows authenticated login. Very simple, create login, quality assurance from Windows. So simple as that, very, very easy statement. Same statements, it's just that this has the from Windows, so it's searching Windows for this account. Click execute, boom, add it in there, no problem. Now what we're going to do, I'm just going to go ahead and go to Window here and hide the results pane. That kind of takes the result pane away. Go into our Object Explorer, into our prod instance that we have connected in Object Explorer, expand the security node, expand the login node. I'm just going to right click here and choose refresh, even though I shouldn't have had to, because it did it automatically for us. There it is, quality assurance, temp tester. Creating schema is pretty simple as well. We just simply use the create schema statement here, followed by the name of the schema. And we're actually going to call this again bug testing. So I'll put a bug in front of it. Authorization, meaning the owner, whoever owns this schema, is going to be, of course, DBO. Next thing we're going to do, I actually am going to create 4 tables underneath the schema. And just by the fact that these are underneath schema here, and before a go statement, it's going to automatically create these tables underneath our bug testing schema for us. So create table, testers, tester ID, first name, last name, and then we have a bugs table with the bug ID, the tester ID of the tester, severity ID of this lookup table, severity, priority ID of the priority table, which is a lookup here, and then the description of the table, and of course the bug, the date and time of the bug as it happened. So we're going to go ahead and highlight all this code, hit execute. Command's completed successfully. We'll hide our results pane here, go into Object Explorer. Let's go ahead and expand our databases, expand AdventureWorks, expand our tables. Look at that. Here they are. Here's all 4 of our tables automatically appended to our bug testing schema. If we go down to security here, into schemas, here's our bug testing schema. If we double click on it, owned by the DBO owner. And that's it. Simple as that. Now moving on down to creating database users. Very simple to do here, just a create user statement followed by the name of the user at the database level, and then for login, whatever the SQL Server login you're mapping it to. So you can see this can be the name, whatever you want. This is the actual, we're creating a brand new database user and just mapping it to a SQL Server login. Same thing if it's a Windows login or a SQL Server Authenticated login, doesn't matter. The database doesn't care as long as it's mapped to something here. So you can see the statement's the exact same. And if we go ahead and highlight this and click execute, boom, commands completed successfully. We'll go ahead and hide the pane here. Jump into Object Explorer and on down to our security area here. Users, I'm going to go ahead and refresh this. There we go. Quality assurance, temp tester, they're both in there. Managing permissions. Let's say we wanted to grant select permissions to our temp tester user on the bugs table. Well, we'll just simply do a grant select on bugtesting.bugs to user. Execute, no problem. Same thing with our quality assurance group, but this is a little bit different. You see I'm using the all statement here. All doesn't really mean all. What all means is these right up here. Select, insert, update, delete, and references, which are the most common permissions on a table object. That's what all means, and all really depends on the type of object you're granting permission to. There's kind of a default setting, but check out books online if you want to know what all means for specific objects. But this is what it means for table objects, and we're going to basically give all permissions to the bugs table to our quality assurance group. So let's go ahead and highlight that and click on execute. And you can see as soon as you execute that permission, it'll tell you the same thing. It actually is maintained only for compatibility and backwards compatibility. It does not imply all permissions defined on the entity. So nice little disclaimer there. Thank you for that. And there we go. So now we have permissions. We have our users on here. And if we go into Object Explorer, just to show you here, and let's go ahead and jump right into a user here, quality assurance. And we go into our securables. We click on add. We'll say all of the objects of the specific type that we're looking for here is tables. About that bugs table. If we scroll down, look at that. There's our permissions set up for us. No problem. Now, one other brief thing I want to show you quick before we talk about controlling execution is if you instead of going through the user to grant permissions, if you want to do it at the object level, you can just simply go to the object, right-click on the object, go to Properties, and then inside of the Properties, you'll see this Permissions tab here, or Permissions node. Looks familiar, huh? Well, you can just click Add here, only instead of now, since we're in the actual object, we're not at the user level asking us to grant permissions on objects, but rather we're at the object level asking us to grant permissions to users. So that's what it's telling us here is, well, what do we want to grant it to? Do we want to grant it to a specific user, a database role, or an application role? So let's just go ahead and say users. That's what we're going to browse for. Click on Browse. Check it out. Here are the users available in this database for us to grant permissions to. Let's go ahead and give temp tester here. We'll click OK. Click OK. There it is. There's our temp tester user. Now we can pretty much do whatever we want. We can give select permissions on this testers table, just as we did before when we were using the interface to do so. And we click OK, and boom. So that's just another way of giving permissions. Rather than at the user level, you can go to the object level. Just kind of wanted to throw that in there for you. So how do we test all these permissions out? Well, we could log off of SQL Server, log off of Windows, log in as someone else with permissions to test these out. We could call the user, have them try to test it out and let us know how it goes. Or we can control the execution context ourselves by using the brand new execute as statement. And what is execution context? Well, it's just simply impersonation. In the simplest form, it just allows us to take our current session, switch it to the security context of another user, and then test it out by executing, statements or whatever we need to do, and make sure everything works as intended. Now, this isn't anything really new. In fact, in previous versions of SQL Server, we had something called the set user statement, which did pretty much the same thing, but it was limited in its ways. Execute as is very powerful. In fact, Microsoft says you should start using execute as and stop using set user because it's only there for backwards compatibility purposes, since execute as is far superior to it. Now, in order to use execute as, you must have impersonate permissions, either at the server level or the database level. At the server level, you'll have it at your login, and then you'll, of course, be able to pretty much use execute as at the server level, any database, anywhere. If you do it at the database level, you only have it in that specific database. But Executing as and controlling the execution time context, great for testing permissions. I've also used it and seen people use this in stored procedures, maybe where the stored procedure is accessing the file system or just doing extraordinary things other than just grabbing data and manipulating data. And you need to execute it as a more powerful user that has security context outside of SQL Server or whatnot. So, many reasons to use and control the execution context. One of my personal favorites though is just doing some testing out permissions as other users, because it's much easier to do this than log off or have them do it. And it's as simple as this. We just do an execute as user equals the name of the user. Boom. At this point, our session, the security of our session is automatically switched to the security of this user. These statements are going to be executed under this user security context, and then revert is going to push us back into our current security context that we're in now. So what's going to happen here is, since our temp tester does not have insert permissions on this bug tables, we should get an error at this point. But the temp tester user does have select permissions on this table, so this should return data. And I put one row of data in here, so we'll be able to see that. I'm going to go ahead and highlight this and hit execute. Check it out. The first statement failed on us. Insert permission denied on object bugs, database adventure works, schema, bug testing. But if we switch over to our results pane, look at that, the select work. There's our bug ID, our tester ID. Again, this is pretty much the one that I put in here. Testing permissions, the date of the bug, and we're all set. So, that's all there is to controlling execution context. Very simple, but very powerful. Alright, so in this CWT Nugget, we took a big look at implementing security. We started off with a look at the architecture behind SQL Server 2005 security model. We looked at principals, securables, and permissions. We saw that principals were the objects that are going to be requesting the resources. We saw that securables were those resources, and that permissions are the actions granted to principals that can be performed on the securables. We then took a look at schemas, and we saw that schemas we now have full control of in SQL Server 2005, and it's going to make our lives a lot easier. We're going to be able to get a little more control and management over our objects and our namespaces within SQL Server 2005. We then took a big look at managing security, threw it all together with a demo. We started off by creating logins at the server level. We then moved in to the actual database themselves and created a schema, created a table, threw that table into the schema, and then we created users. And we created database users, mapped them to those SQL Server logins, and then we also granted permissions to the objects in the schema to those users in the databases. And we also took a look at some roles there too, the server roles, some database roles. And at the end here, just to kind of show you both sides of the coin, we took a look at the scripting version of doing everything through the interface. And we also at the end took a look at controlling execution context. Kind of give you a brief overview there on how powerful it and very useful it is to understand context switching and how it works and how to do it. So I hope this has been informative for you, and I thank you for viewing.